Hello, and welcome back to Error Analysis Essentials, a series by Physical Sciences Consultorium. I'm Saba, and if you've been following along, we've already covered some foundational topics. In our first 3 episodes, we introduced error analysis, explored the differences between systematic and random errors, and discussed measurement uncertainty, accuracy, and precision. Today, we're diving into a concept that's absolutely crucial for precision in your scientific work: significant figures. This episode will help you understand why significant figures matter and how to use them correctly in your measurements and calculations. In the simplest terms, significant figures are the digits in a number that carry meaningful information about its precision. They help us understand how precise a measurement is and how much confidence we can place in that measurement. To put it another way, significant figures include all the digits that are known with certainty plus one last digit that is estimated. For example, if you measure a length and record it as 12.34 centimeters, all 4 digits are significant because they convey meaningful information about the precision of your measurement. The concept of significant figures ensures that when we report measurements, we reflect the true precision of the data. Now, let's break down the rules for determining which digits in a number are considered significant. 1. All non-zero digits are significant. 1. For instance, in the number 123.45, all 5 digits are significant. 2. Any zeros between significant digits are also significant. 2. For example, in the number 1002, all 4 digits are significant. 3. Leading zeros are not significant. 3. These are the zeros that come before the first non-zero digit. 3. In the number 0.0056, only the digits 5 and 6 are significant. 4. Trailing zeros in a decimal number are significant. 4. For instance, in 12.300, all 5 digits are significant because the trailing zeros indicate the precision of the measurement. Let's look at a few examples to clarify these rules. 1. In 0.00345, there are 3 significant figures, 3, 4, and 5. 2. In 2500, without a decimal point, the 2 and 5 are significant, but the zeros may not be, depending on the context. 2. If the number is written as 2500, then all 4 digits are significant. Understanding significant figures is crucial when performing calculations. Let's look at how they apply in different mathematical operations. 1. Addition and subtraction. The result should have the same number of decimal places as the measurement with the least number of decimal places. 1. For example, if you add 12.11 centimeters and 0.4 centimeters, the result should be reported as 12.5 centimeters, not 12.51 centimeters. 2. Multiplication and division. The result should have the same number of significant figures as the measurement with the fewest significant figures. 2. For instance, if you multiply 2.34, 3 significant figures, by 1.2, 2 significant figures, the result should be reported with 2 significant figures, so 2.8. Always remember to round your final answer according to these rules to maintain the correct level of precision. Even though the rules for significant figures are straightforward, it's easy to make mistakes, especially when you're in a rush or dealing with complex calculations. Here are some common mistakes and how to avoid them. 1. Miscounting significant figures, especially with zeros. 1. Always remember the rules for leading, trailing, and in-between zeros. 2. Ignoring significant figures in intermediate steps of a calculation. 2. It's important to keep track of significant figures throughout your calculations, not just in the final answer. 3. Rounding too early in a calculation. 3. Avoid rounding numbers until you reach the final step, as this can introduce additional error into your results. By being mindful of these common pitfalls, you can improve the accuracy and reliability of your measurements and calculations. Why are significant figures so important in practice? In scientific research, precision is everything. Whether you're measuring a chemical concentration, calculating a force, or reporting the results of a medical test, using the correct number of significant figures ensures that your results are accurate and credible. In summary, significant figures are essential for maintaining precision in scientific measurements and calculations. By understanding and applying the rules of significant figures, you can enhance the accuracy and credibility of your work. If you found this episode helpful, please give it a thumbs up, share it with your colleagues, and don't forget to subscribe to our channel for more insightful content. We'd love to hear your thoughts and questions in the comments below. Thank you for joining us for this episode of Error Analysis Essentials. In our next episode, we'll explore the concept of error propagation and how it affects the results of your calculations. See you next time.